Now let's talk about something called higher order derivatives. And I'm skipping to page 36 in your notes packet. Higher order derivatives are like taking a derivative over and over. So you'll hear me say, whenever we've been taking the derivative, we've been taking the first derivative. But you can take something called the second derivative by taking the derivative of the derivative. And we'll learn about that, the meaning of that later in the course. But for right now, you just need to know how to find it. Here's some notations. So if you're using, so here's notation for first derivative. So if your function was f, the first derivative notation would be f prime or y prime, which Miss Honeycutt doesn't love, over or dy dx for the first derivative. Second derivative, you would see y double prime or f double prime or y double prime, or we say d2y dx2. Here's notation for third derivative, and nth means any number after that. So any number after that will be set up that way. And we start putting a number here because it gets taxing, drawing all those tally marks and then having to keep track of how many there are. So right here, we're asked to find the second derivative. And notice right now, I just have the original function. So to find the second derivative, I need to find the first derivative first. So f prime of x would be 3 times 8/3 is 8x squared minus 2 times -5 is 10 x to the first minus 7. First derivative. To find the second derivative, I'll take the derivative of the derivative. So f double prime of x is going to be 16x, because 2 times 8 is 16. Subtract 1 minus 10. Second derivative. For part B, you first need to change the original function by dividing everything by x. So x squared divided by x is x. 4x divided by x is plus 4. And then -2 over x you can write as -2 to the x and -1. Then you would find the first and second derivative from there.